Now, example number 1 on octal and denary number systems, you've been told there, Roman number 1, to convert 613.24 to base 8 to denary, meaning you've been told to convert an octal number system to denary. So if you convert that, you'll get 395.3125 to base 10. Then if you convert the second one, which is denary to octal, you'll get 613.24 to base 8. So how do we convert an octal number system to denary? Remember, we said converting any number system to denary number system, you simply look for the total value of that number. Now, the number system, the total value of any number system is always to base 10, is always a denary number system. So if you want to convert an octal number system to denary number system, you simply look for the total value. And remember, the total value is summing up all the digits with their respective place values. And in the place values, remember, if it is an octal number system, then the base is 8. So in place of place value, when we are dealing with an octal number system, we put base 8 in place of place value. So Roman number 1 there, we want to convert 613.24 to base 8 to denary. Denary is base 10. So base 10 means we look for the total value. So on the decimal side, we have 0.24. Then on the whole part, the first digit on the whole part is 3, then followed by 1, then followed by 6. Then we put our place value. So in the place values, you start by putting the base. The base is 8. So our place values, the number system we are converting 613.24 is to base 8. So we put base 8 for all of them. So in place of place value, we put base 8 because that number system is to base 8. After that, on the decimal side, we have raised to -1, raised to -2. On the whole part, we have 0, 1, 2. In that order, you know how to put the place value of any number system. So the total value of that number system will be the place values times the digits itself. So if you sum up all that, you'll get 395.3125. So if you multiply the place values and the respective digits and you sum all of them, you will get the total value of that number, which is 395.3125. And that number system is to base 10. So the total value of any number system is always to base 10. Now, Roman 2, you now want to convert a denary number system to octal. Denary number system is to base 10. So base 10 means you are converting the total value to octal. So if you are converting to octal base 8, meaning whole part you divide by 8, decimal part you multiply by 8. Remember, whole part is divided, decimal is multiplied. So whole part you divide by 8 until you get a 0 while you record the remainder. Decimal part you multiply by 8 while you record the whole part which has generated. And remember, all part moves upwards, meaning you record the remainder from down coming on top. Decimal parts move downwards, meaning you record the first generated whole part up to the last one. So we start with the whole part, we have 395. The decimal part we have 0.3125. So let us start by converting 395. So remember, 395 is to base 8, meaning we divide by 8 until we get 0. So 395, if you divide 395 by 8, what do you get? So if you divide 395 by 8, you'll get 49 remainder 3. So it is the remainder we are recording. So we get 49 remainder 3 out of 8. Then now 49 divided by 8. 49, if you divide by 8, you will get 6 remainder 1. Then 6, if you divide by 8, you get 0 remainder 6. So the moment you get 0, you've reached the end. So that whole part is recorded from downwards. So you record the remainder from downwards. It moves upwards. So it means you are going to record 613. It moves upwards, meaning you record from the downer generated remainder. So the whole part will be 613. Then you go to the decimal part. Remember, the decimal part is 0.3125 to base 8. So when the base is 8, the decimal part we multiply by 8. because the base is 8. It is 0.3125 to base 8. So the decimal part is multiplied. So you multiplied with the base you've been given. We've been given base 8. So that is to base 8. If you multiply by 8, you get 2.5. Record the whole part which has been generated, which is 2. Then you keep the remainder. Then you keep the decimal part, which is 0.5. So the number is, then that 0.5 is what you multiply by 8. You record the generated whole part. Then you continue with the remainder. So the generated whole part is 4. So it means on the decimal side we are remaining with 0. So the moment we remain with 0, it means we've reached the end. So the whole part is what you record. Then the remaining decimal part is what you continue multiplying until you get 0. So we found 0. It means the process has terminated. So the decimal part is recorded downwards, meaning you start with the first generated whole part, which is 2 followed by 4. It is recorded downwards. So if that number system to base 10 is converted to octal, you will get 613.24. So that 613.24 is now to base 8. You've now converted it to octal number system. So that is how we convert any number system to an octal number system.